So finally, let's start with the zeroth law of thermodynamics. There are a few terms to know before we start off. So we'll be using this in stating the zeroth law. First is thermal contact, thermal equilibrium, and transitivity. You guys can guess. You can close your eyes, take a guess. What does thermal contact mean? Thermal and contact. Okay, you have some idea? Done. Thermal equilibrium. We have kind of studied this. Equilibrium we already studied. Thermal equilibrium. Then we have, you might take a guess. You can take a guess. Transitivity. Try to guess what can be transitivity. Okay, so let's read through. Thermal contact. Two objects are in thermal contact if they can exchange energy, heat or electromagnetic radiation due to thermal difference. So if it's allowed, there is a way that two objects can exchange energy in the form of heat or electromagnetic radiation. They are said to be in thermal contact. Okay, so heat and electromagnetic radiation, those two has to be defined. That also will be defining. So this actually definition depends on one more thing. So you can see everything is interconnected. But yeah, we have to build. We have to, like in wall climbing, you jump and you hold the next grip, right? So in between, you are kind of free falling. So that's how it is. So you have to free fall a bit. You have to somehow do a bit of jugaad and move forward. So let's move forward. Thermal equilibrium. Two objects are in thermal equilibrium if they do not exchange energy when placed in thermal contact. So no net heat flow occurs. So that is kind of simple. So if you have two things which are of same temperature, if you touch them, there is no exchange, or if there is exchange of energy, the net is zero. Transitivity is a mathematical property where if one thing relates to the second and the second thing relates to the third, then the first also relates to the third. Right? Commutative law, transitivity. Remember, if 1 is parallel to 2 and 2 is parallel to 3, 1 will be parallel to 3. That's what we're looking at. Okay, with all of that in mind, let's actually state zeroth law of thermodynamics. So you can see over here, we have 1, 2 and 3, ABC, right? So if object A is in thermal equilibrium with object C, and object B is also thermal equilibrium with object C. So A is in equilibrium to C, B is in equilibrium with C. Then object A and object B are in thermal equilibrium with each other. This might sound quite obvious and to a certain extent stupid. Right? It's like, why are we even telling this? Again, the very basic definition builds the complex concepts. So yeah, this is very simple. That's true. A is in thermal equilibrium with C. C is in thermal equilibrium with B. A has to be in equilibrium with B. Right? Make sense? Now, thermal equilibrium is transitive. Right? So first we'll be talking about, with this statement, if this is commonsensical, with this we can derive few things. We can borrow or we can extract few ideas. Thermal equilibrium is transitive, right? You understood transitive over here. Mathematically, what does transitive mean? Just like equality in mathematics. A is equal to B, B is equal to C, so A is equal to C. It establishes the concept of temperature as a measurable and comparable property. So if you think that, we are able to compare things. If you are able to compare things means what? Eventually you'll be able to measure them and everything else follows. So this zeroth law lets us know that yes, this is measurable. It is doable. We can proceed with it. It gives us a green flag. Again, it's a very simple statement, but it opens up a gate that will allow us to learn thermodynamics. It allows us to use thermometer, right? If thermometer object C is in equilibrium with object A and B, then A and B must be at the same temperature. That's how you build a thermometer, Thermometer, what is that term? You basically measure at 0 degree and 100 degree and you see that the relationship is linear. Then you divide the entire scale into equal parts. So anyways, point is we are able to build thermometer with this idea. Okay, that's the implication of this very simple statement. Definition of temperature. You are able to define temperature. Temperature is the property that determines whether two objects are in thermal equilibrium. Okay, so we have defined the idea of thermal equilibrium. Using that, we are defining temperature. The starting point is thermal equilibrium, right? If two objects are in thermal equilibrium, they're said to have the same temperature. Does it make sense? Now, temperature and molecular motion. In gases, temperature reflects the average translational kinetic energy of the molecule. Higher temperature means molecules move faster. Lower temperature means molecules move slower. In gases, temperature reflects the average translation kinetic energy of the molecule. Okay, yes, again. So all of this you will be studying in kinetic theory of gases and everything, but a small introduction again. So please copy this. Zeroth law is that simple, guys. I can't make it more complicated. So if you're wondering, it should be very huge thing, but it's not. It's a very simple thing. That's the smart. You have done something really smart when you can keep things very simple. That's about smartness.